Now watch this page table entry. So page table entry is nothing but what is that will be present in the page table. So most important thing is page frame number, isn't it? Which means what I mean to say is this is the page table, right? And these are the page table entries. And whenever any process is running on the CPU will generate the logical address, right? Whenever any process is running on CPU will generate the logical address, and logical address will contain two parts. One is page number and other is page offset, right? And now depending on the process, let us say the process is P1 and this is the main memory. Inside the main memory, the process P1 is going to be present at any frame. These are all the frames, and P1 may be present like this, right? P1 like this, 4 frames. And now the page table entry should point to, let us say this is page number 0, right? And it should point to the frame number in which page number 0 is present. Maybe this frame might be frame number 10, then it should contain 10, right? Then how are you going to go there? You are going to take the page number and you are going to go into that page number, right? But then there is one more part here. CPU should also know where the page table is placed. So for that reason, CPU will have a register, right? In that register, special register that will contain page table base address. Base address means what is the starting address of the page table. And now whenever you try to take the page number, we are going to take the page number and we are going to add it. We are going to take the page table base and we are going to take the page number and we are going to add these two. Then only we can go to the exact address where the page is, right? In case if the page number is 10, then if the page base is something here, then if I add to the page base the page number, then it will obviously go to the 10, right? And it is also called as scaling. Scaling means even though I am adding a page number, the adder should appropriately scale it in such a way that I'll cross those many pages depending on the page table entry and I'll reach the correct entry. And from there the page table entry will point me to the frame, corresponding frame, whatever it may be. Are you following this? So CPU should know where the page table is present. For that reason, it is going to have something called as page table base address, which is going to say the starting point of the page number, page table, and then to the base address of the page table, I am going to add the page number in such a way that I can directly go into the page table entry, which is corresponding to the page number, which is corresponding to the page which is required. And once I get into that page, I can take out the frame number and I can go into the main memory, right? And once how can I go into the main memory? See, in the middle there is one more procedure remaining. So once you get the frame number, you take the frame number, right? And you take the page offset and you put the page offset here, and combined it is going to be the physical address. This is logical address and this is physical address, and actually this physical address will go and refer into the main memory. That is what is the entire procedure. But now along with this frame number, some more information will be stored in the page table entry. So what is that entry is? Watch it. It will have many fields. So actually this information varies from operating system to operating system, and what is that I am going to tell you here is the most generic way. I'm just generalizing it, but the actual details they vary from OS to OS, right? So one entry is caching disabled. So what do I mean by caching disabled is, sometimes we don't want a page to be ever present in the cache. So what are the situations where we need it is, sometimes we need the fresh data. Let us say user is typing some information from the keyboard and your program should run according to the input given by the user. In that case, the information will come into the main memory, right? Therefore, main memory contains the latest information which is typed by the user. Now, if you try to put that page in the cache, that cache will show the old information. So, whenever freshness is required, we don't want to go for the caching or many levels of the memory. What happens is always the information present in the closest level to the CPU and the information present in the closest level to the user, they might be different, right? So what we want is the information has to be consistent, which means whatever information user has given, CPU should be able to see it as fresh as possible. That is the reason we want to disable caching. So this bit is going to mention whether this page should ever be carried into the cache or not, or it should be left in the main memory itself. And next one is referenced. Reference bit will say, this is a reference bit. See, these are all bits, okay? Reference bit will say whether this page has been referred. So why is this useful is, later I'll tell you about the page replacement algorithms. So whenever we want to replace a page, in order to get some other page because of the lack of space, we try to replace the page which is not referred recently. There are various algorithms, least recently used like this. There we are going to see this. Anyway, this bit says whether the page has been referred in the last clock cycle or not. What is a clock cycle? What is reference? We shall see it later. And next one is modified. Modified bit says whether the page has been modified or not. Modified means sometimes we might try to write something onto the page, right? Why is it important that you know that a page is modified is, if a page is modified, then whenever you should replace that page with some other page, then this modified information should be kept in the hard disk, or it has to be written back, or it has to be saved back. Whenever you try to pull out a process from the main memory in order to get other process, you should see that all the pages which have been modified should be reflected in the hard disk, because later that information might be useful, right? So for that reason we are going to use modified. And sometimes this modified bit is also called as dirty bit, right? Saying that the page is dirty. Dirty means you modified it. So whenever you try to pull it back, you have to again write it back. So whenever you try to replace a dirty page, then the time taken will be writing back that dirty page onto the hard disk and then getting a new page and putting it in the main memory, right? And next one is production. So production bit says that what kind of protection you want on the main memory, that page. Sometimes you might want users to use it in only read-only mode, or read and execute, or only execute, or read write, something like this. There are various types of protections you can assign. So it is not a bit, this is a field which is containing many bits, and each bit will define whether it is read only, or read write, or execute, or read write execute. So depending on what you want your page to be acted like, you could put these protection bits. And next one is present or absent. So present or absent are going to be important whenever you have this virtual memory concept. In virtual memory concept, I told you that in order to run a process, we need not have all the pages in the main memory. Then what we do is, some of the pages we'll put them in the main memory, and other pages they will be loaded whenever there is it is required. That is called as demand paging. Demand paging is, we are not going to load all the pages at once, we are going to load the page only when it is required, right? Now if that is the scenario, then it might be the case that all the pages might not be present in the main memory, right? And then we have to understand what are the pages which are present in the main memory and what are the pages which are absent. So this present or absent bit will show whether this particular page you are looking for is present or it is not present. In case if it is not present, that is called as a page fault, which means CPU wants a page and that page is not in the main memory. Where will that page be? In the hard disk. Then you have to get the page from the hard disk and put it in the main memory and give it to the CPU, right? Then in that case, these bits are going to be useful. So if the page is absent, it is called page fault. Then we will try to load the page and then give it to the CPU. In that meantime, it is a time waste, isn't it? The required page is not present, therefore CPU cannot continue further. In that case, what happens is, this process will be kept in the waiting queue, again waiting for the event, which is nothing but the hard disk, right? So once the hard disk provides you with the information, that page, you can again resume the running. That is called as page fault. We shall see the page fault later. And present or absent, that is what. And finally, the most important information is page frame number. So what is page frame number? It gives the frame number in which the current page you are looking for is present in. That is what is required finally, right? So this is the most important part, and all the other parts, they actually vary from implementation to implementation. Anyway, every operating system is going to maintain some information along with the page frame number. Till now, the questions which we have solved assume that there is no information present in the page table entry. That is why I have taken that page table entry size equal to page frame number size, but which is not right always, right? So there can be some questions possible like this. They will say that page table entry size is so and so. Then how many bits do you think would have been given to other bits like this? Then protection bits, dirty bits, everything put together, how many bits would you would have given that? So some questions are possible like this. We shall solve it, right? So this is all about the page table entry, and actually this one varies from textbook to textbook and from implementation to implementation, but this is the most generic one I have taken, right? Okay.